Hi, today we're going to work with simplifying negative exponents. Back when we were working with dividing with exponents, when you subtract the exponents, there was when we did it back then, a positive answer, meaning a positive exponent, where you had more x's on the top. So if you had x to the fifth divided by x cubed, you can subtract, and 5 minus 3 gives you 2, so you have x squared. However, right down in here, when you subtract the exponent, you might get a negative answer if you have more x's on the bottom. But before we get into that, remember the expanded form. If you have x cubed, that means 3 x's on top, all divided by x to the fifth would be 5 x's on the bottom. So remember how you cancel out a pair? Cancel, cancel, cancel. And then what you have remaining is in the denominator, and you have 2 of them, so that would be x squared. And then you would have to have a placeholder in the numerator, which would be the 1. Now then, so basically you went from here all the way to this answer when we did it before. Now then, let's just kind of take a look at this. What if we went ahead and used the subtracting, meaning you take the exponent in the numerator minus the exponent in the denominator. So you get 3 minus 5, which is a negative 2. Now then, what we're going to do is we're going to convert any negative exponent to a positive exponent. So we can treat this as x to the negative second over 1. What we're going to do is we're going to take this whole term, x to the negative second, and move it to the bottom. And then convert the negative 2 to a positive 2. So that's basically what we're doing today. So on problem 1 here, this is understood to be over 1 as a fraction. So we're going to take x to the negative fifth and move it to the bottom. So that's going to become x raised to the positive fifth power. Now then, we need a placeholder. So we're going to put a 1 there. All right, number 2, this is like over 1. So we take that, move it to the bottom. So this would be 1 over a to the positive 3. Number 3, you need to read over here in the box. Only the n is raised to the negative power. So if we make this over 1, only the n will go to the bottom. So you actually have something in the numerator, and that's the 5. So it'll be 5 over, and that 1 here in the denominator, again, that's just the placeholder. So it would be 1 times n squared, which would just be n squared. So on number 4, let's move this paper up a little bit. On number 4, this is over 1, and we're going to do this the same, in that the x to the negative 6th power is going to go to the bottom. That negative 4 is going to stay in the numerator, so it'll be negative 4 over x to the positive 6. All right, number 5, we have x to the negative 4th divided by x squared. So if we subtract the exponents, that will give us negative 4 minus 2. Negative 4 minus 2 gives you negative 6. So this would actually be x to the negative 6th power. But remember, if we want to convert it to a positive exponent, we're going to make that over 1. So we're going to take this and move it down below. So this would become 1 over x to the positive 6. On number 6, I'm going to show you a different way than what I did on number 5. I'm going to show you actually moving this negative exponent, the term with the negative exponent, to the bottom and making it a positive exponent. And if we do that, it's going to become times a, and that negative 1 is now going to become a positive 1. So we need a placeholder in the numerator, so we're going to put a 1. over a to the, now remember back when we were multiplying with a common base, you added the exponents. So this would be 6 plus 1, which is 7. So a raised to the 7th power. So that's just another way to actually get your answer. So you can either do it like I did on number 5, or you can move it down and do it like I did on number 6. Now then, down here it says, what if the negative power is in the denominator? So all the ones up above on 1 through 6, the negative exponent was in the numerator and we moved it down. So all you're going to do, if it's down here, you're just going to move it up. Okay? So on number 7, all you're going to do is take this and move it to the numerator. So this will actually look like 1 times n, and that negative 5 becomes a positive 5. So 1 times n to the 5th is just n to the 5th power. Number 8, a couple ways you could do this. You could move this to the top, and anytime we move something from its location, whether it's top to bottom or bottom to top, it's going to be multiplication. So we're going to say times x, and now since we're moving this to the top, it's going to become a positive 2. And when we multiply with the common base, you add your exponents. So this would be x to the 6th power. On number 9, we can do the same thing here. And we can move that. I was going to show you another way. Sorry about that. Okay, so another way that you could do this is you could actually subtract the exponents. So this would be 2 minus a negative 6, which becomes a positive 6. So this answer would actually be a raised to the 2 plus 6 is 8th power. So that's just another way that you could work that, or you can work it like we did on number 8. Okay, number 10, we're going to take this and move it to the top. So we're going to have 3 times x to the 1st power, which is just 3x. Number 11, we're going to take only the x term and move it to the top. Leave the 4 alone. The 4 itself actually has a power of 1. So this will be 1 times x to the 8th, or just x to the 8th, all divided by 4. Number 2, let's see. You could do this a couple ways. I think I'm just going to go ahead and take this and move it to the top. So this would be times x to the to the positive 5th power. And then we can add our exponents. So negative 2 plus 5 is 3. There's some other ways you could do this. There's like 3 ways you could simplify this problem. I may go ahead and take the time and show you. Another way is you could flip both the numerator and denominator because they're both negative. If you did that, you would have x to the 5th over x squared. So when you flip their location, they just change and from the negatives to the positive. And then you could subtract. 5 minus 2 is 3. Okay, so you get x to the 3rd power. And then one other way that you could do this, I'm going to go ahead and erase this, so that you can see another way. Another way is you could go ahead and, without moving the denominator, you could go ahead and subtract the exponents. So you start with negative 2 in the numerator, subtract a negative 5. So minus a negative becomes a positive. So their negative 2 plus 5 gives you the positive 3 that you had. So there are 3 different ways that you could work that problem out. All right, moving on to down below, it says anything raised to the 0 power is 1. Okay, so let's just kind of go over some things that actually equal 1. So 5 divided by 5 is 1. X divided by X is 1. 5a divided by 5a is 1. X to the third divided by X to the third. And so what happens is these x's all cancel out in expanded form and it equals 1. I want to go ahead and talk about this one just a little bit more. I think anything to the 0 power will make more sense on this problem. So you know how we were talking about when you divide with a common base, a shortcut is to subtract the exponents. So if I take the 2 exponents, 3 minus 3, 3 minus 3 is equal to 0. And that's exactly what happens. You don't have any other exponent. 3 minus 3 is 0. So basically, this would be x to the 0 power. And the reason why you don't have any more x's is because they all cancel out. So long story short, anything to the 0 power is equal to 1. Just like the word same divided by the word same. The S, the A's, the M's, the E's all cancel out. When you divide and they cancel out, it cancels out to be a 1. All right, let's go ahead and look on the back side. When you subtract the exponent and it is 0, so this is a carry over. I didn't realize that, but this carries over to what I was just explaining. When you subtract the exponent, 3 minus 3 is equal to 0, and anything to the 0 power is 1, because if you were to write it in expanded form, which I showed you on the other side, that gives you, they all cancel out to be 1. So on problem 1, anything to the 0 power is 1. And you could even put, if it's a number like this one, 2 to the 0 power, if you put that in your calculator, 2 raised to the 0 power and hit enter, it's going to say 1. Negative 1 to the 0 power is 1. N to the 0 power is 1. Now, number 4 and 5 are just a little bit different. Negative 6 is not raised to the 0 power. Only the x is. So what you could do is split it apart. So this will be negative 6 times, and x to the 0 power is 1. So negative 6 times 1 is negative 6. Now then, number 5 is just a little bit different. What you would do is bring this negative 1 down. Bring down the negative. Sorry about that. You would bring down the negative, and 1 to the 0 power is 1. Okay, so that answer is actually negative 1. So you see the difference between number 2 and number 5. Number 2 has the negative 1 in parentheses. So all of that's raised to 0 power, that's 1. But on number 5, the negative 1 is not in parentheses. So the negative, your answer is going to be negative, and then 1 to the 0 power is 1. All right, so let's kind of take a look at what a table of value looks like using some fractions with some negative exponents. So on this one, when we start with 3 to the 4th power, I look at that as 3 times 3 times 3 times 3. So when you have 2 3's multiplied together, it's 9. 9 times 9 is 81. So then this exponent with a base of 3, this one would be 3 to the, and we're just going to go down from 4 to 3 to the 3rd power. 3 cubed. 3 times 3 times 3 is 27. 3 squared is 9. 3 to the 1st power is 3. So if we're going down with the exponents, 4, 3, 2, 1, Guess what this one's going to be? 0. So anything to the 0 power is 1. All right, 3 to the negative first. So let's treat this kind of like a fraction. Remember what we do with negative exponents? We move their location. So we're going to move that to the bottom. So we're going to have a 1 in the numerator, and then it'll be 3 to the positive first in the denominator. And 3 to the positive 1 is just 3. Okay, so now if we are 4, 3, 2, 1, 0, negative 1 as your exponents, guess what this one's going to be? Negative 2. So, and you can put these in your calculator because they don't have a variable with it. Or we can do it the long way. So this is like 3 to the negative second over 1. So you're going to take this and move it to the bottom. So it'd be 1 over 3 squared, and 3 squared is 9. So that's where we get 1/9. All right, let's take a look at the middle one. We have 10 to the 4th. So that's 1 with 1, 2, 3, and 4 zeros. So guess what this one's going to be? 10 cubed. 10 squared is 1 with 2 zeros. Then this will be 10 to the first, which is 10. 10 to the 0 power, anything to 0 power is 1. And if we want a fraction, then it's going to be a negative exponent. And then 10 to the negative second, that's like over 1. So you're going to take that, move it to the bottom. So it'll be 1 over 10 squared. And 10 squared is 100. So 1 over 100. So now when we're working with exponents, we have a cubed. Just simplifies to nothing other than a cubed. A squared is a squared. A to the first is a. A to the 0 power is 1. A to the negative first, guess what? We have to flip it. So it'd be 1 over a. And then this would be a to the negative second. And a to the negative third would be 1 over a to the positive 3. All right, so now let's just kind of pull everything together and see what we can do with this. So it says try these. It doesn't say anything about writing with positive exponents, but that's what we want to do here. So on this one, it's like over 1. So we're going to flip it and be 1 over r to the 8th power. On this one here, only the c is going to be moved. So it'll be 5 divided by c to the positive 3. On number 3, we're going to take that and move it to the top with a 1. So basically, it's just going to be n cubed. Number 4, remember there's a couple ways that you can work this. You could go negative 4 minus 6 and get a negative exponent, or you could take this and move it to the bottom, so it'd be times a, and that negative 4 would become a positive 4. So your placeholder in the numerator is a 1. When you multiply with a common base, you can add the exponent. So 6 plus 4 is 10, so it'd be 1 over a to the 10th. I think I'm going to go ahead and just move this to the top. So it'd be times n, and that negative 2 becomes a positive 2. So now I have 3n to the 4th power because 2 plus 2 as an exponent is 4. Number 6, x to the 0 power right here, that's a 1. So basically it looks like 3 times 1, which is 3. Number 7, all of this 2n is in parentheses, so it's raised to the 0 power, so that's equal to 1. Let's take a look at number 8. So if we subtract our exponents, 3 minus 3 is 0. And anything to the 0 power is 1. So basically, you're just going to be left with 5. Another way to look at this is you could look at it in expanded form. I have 3 x's on top with a 5 and another 3 x's, but in the denominator. So what happens here? Cancels, cancels, cancels. So your final answer is just 5. Number 9, x to the 0 power is 1. And then over, and that x to the 5th, it's a positive exponent. So we're good. 1 over x to the positive 5.